Well, in this video, I will show you how to draw free body diagrams on an object and in order to analyze the motion of it. Well, you can actually try this experiment at home. Prepare a water bottle and then place a cardboard on it and then place a random object on it. And this random object, it should be small enough for this experiment. Oh, and the next task is that you use your finger to remove the cardboard in between suddenly, quickly, and to see what will happen to the object you place it on the top. And here is part of the result. What I use is a green cap. After I remove the cardboard, then it will fall down into this bottle. Why? Oh, and secondly, is that again find a random object and then by use a rubber band on one of the sides, and then on the other side you use your fingers to hold it and keep it at rest, and then release your finger maybe in this diagram on the right hand side. What will happen to this box? Oh, and then thirdly, you can use two rubber bands with a random object, and then you try to lift it up by these two rubber bands. And what I want you to observe is the angle of the two rubber bands. Can you make these two rubber bands horizontal? Oh, let's move to the next part. It's the discussion of how to draw a free body diagram. According to the Newton's first law of motion, if there is no net force acting on an object, it will remain its original motion state. That means if originally it is at rest, then it will remain at rest. If it is originally moved in a certain direction in a certain speed, then it will also keep this speed and also its direction of motion. That is, it will not speed up, or it will not slow down, or it will not change the direction of motion. 中文叫咩呢？靜者行靜，動者常動。Oh, how to draw the free body diagram of an object? And I think you need to know two things first. First of all is that how to represent a force in science. You use arrow to represent this force when you are drawing the free body diagram. And the use of the arrow is, first of all, show the direction of the force. And secondly, the longer the arrow you draw, then the stronger the force is. And then third is that the arrow should start from a position in which the force starts from. And I will illustrate it later in the example. Oh, now, when you're holding a green object and then if you suddenly release your finger and then to release this green object, what will happen to it? Or it will fall into the bottle, or it will fall downward. And why? What force make it to do so? And some of you may get the answer. It is the force of gravity. 咁啊，地心吸力啦，重力啦，係嘛？我指向邊度啊？指向地心。Oh, and because for this gravitational force or a force of gravity is a long contact force. So when we are drawing the arrow representing this object, it starts from the center of gravity of this object. And because this green cap is quite symmetrical in shape, so I assume that is at the middle of it. And secondly, as I mentioned, the arrow showing the force also show you the direction. Then what should the arrow point to? Okay, downward. 指向落啦，係咪？ And the third thing is that label the force. You can call it the force of gravity, gravitational force, or if you give it a more specific description, it is actually the force exerted by the Earth on this object. Well, and now I think you can see the overall effect of the forces acting on an object, because now there is only one force and this force is pointing downward, so that this force will make this green object to accelerate downward. And my question is, why don't we need to draw the bottle or the table? And just like this, we can call it the free body diagram on this green cap already. Why? It is because the idea of free body diagram is in order to show all the forces on an object and then to see the overall effect. So what we want to focus on is this green object, so that for the rest of the bottle, the desk, or the chair behind, we do not need to draw it. Oh, and let's see a more complicated case, and then I think you will have more understanding about what I'm talking about. Oh, and in the second case, we again have our green object and then with a bottle. However, this time we place a card on the bottle and then put this green object or the random object you have on the cardboard. But this time, it will not fall down. Why? And obviously, the Earth is acting the force of gravity on this object. But why this time the green object remain at rest? What is giving it the support? 嗱，好明顯啦，地心吸力長時間都將你拉緊落去啦，係嘛？咁點解而家呢個 case 呢嚿綠色嘅嘢佢唔跌嘅？Oh, and you can have the idea that the cardboard give the green object a support, is it? Oh, and what should this force pointed to? This supporting force, upward, downward, to the right-hand side or right-hand side? It should give it upward force to support this object. So let's move on to the free body diagram of this green object in this scenario, and just draw the green cap, although I'm using a red pen. Then why do we need to draw the bottle, the desk, or the chair? It's because for this free body diagram, we would like to show all the forces acting on the green object only, but not want to show the forces acting on the rest of the object. So just draw the green object or the object you want to focus on or you want to analyze. Oh, and the first force is the force of gravity pointing downward, or we say that is the force exerted by the Earth on this object. Oh, then how about the supporting force? Well, it should point upward. Then how about the magnitude? 個數值係點啊？向上啦，數值應該係點？Okay, it should be equal to this gravitational attraction in order to make this cap remain at rest, is it? Oh, and there are several important points. And because force of gravity is a long contact force, so when we are drawing it, you start this force from the center of gravity of this object. However, for the supporting force by the card on this object is a contact force. Where should it start from? It starts from the place that the green cap contact with the paper. So start from here and then pointing upward. And as I mentioned at the very beginning, the length of the force representing how strong the force is. Now, because you would like the supporting force cancel the effect of the gravitational force. So these two arrows should with the same length. However, they are opposite in direction. And I label it first. That is the force exerted by the card on the object。咁而家見到一個向上，一個向下，係嘛？但係數值一樣，咁會點啊？抵消咗。好 ，and we call this case the net force equal to 0. And the meaning of net is that there may be several things affecting an object or several processes affecting an object. And in this case, there are several forces acting on this object. And after we consider all the forces, then the overall effect is what? And this time, because the two forces, they're opposite in direction, but with the same size, so that they cancel out each other. So we use the term net, and then because now the net force is equal to 0, so this object will remain its original motion state. And at the moment I place this green object on the cardboard, it is remain at rest, and there is no net force acting on it, so it will remain at rest. 靜者行靜。What happened if I suddenly remove the cardboard in between? What will happen? This is the case with the cardboard. So I suddenly remove the cardboard very quickly by my finger. Which of the force will no longer exist? Okay, the supporting force will no longer exist. That look like this. Then at the moment that I remove the cardboard, that is the cardboard flies away, what will happen? What is the net force? Is it still equal to 0? And this time, no. And this is the new free body diagram after I suddenly remove the cardboard. And as you may see, there is only one force acting on the object, and it's pointing downward, and it's the force of gravity. So the object will accelerate downward again without any support. So if you really perform this experiment at home, then the green cap or the random object you choose will fall into the bottle. Well, then let's move on to a more complicated case. It's like this. And you can also do it at home. Just find a random object, a piece of rubber band, and then to hold the object, and on the other side, your goal is to make this object remain at rest. So when you're drawing the free body diagram, or you would like to analyze the motion of this blue box, what should you draw? Should you draw the rubber band? Should you draw the finger, or should you draw the table in the free body diagram? The answer is no, because you would like to analyze the effect or the motion on this blue box only. So let's draw it, a blue box. 我淨係想知道所有嘅力加喺呢一嚿嘅藍色盒上邊嘅影響，總體嚟講係點啫？係嘛？我淨係畫呢個 box 咧就夠㗎啦。Oh, and obviously there is force of gravity acted by the earth, but why it will not moving upward or moving downward? 明明擺張台度啦，係咪？亦都應該有地心吸力啦，拉住呢嚿嘢。點解佢唔會向上升向下跌嘅？呢個藍色盒。好 and just try to draw these two components first. First one is that there is a force of gravity. Well, actually, we can call it weight. But why it will not fall down? And obviously, in this case, is it a table is below, and then to support this box, and then to give it a supporting force. Oh, and because supporting force is contact force, so we start from the place where the box and then the table are in contact, and there's a force exerted by the table or the desk on the box. And these two forces should be the same in length to represent that these two forces have the same magnitude, and then these two arrows should be in opposite direction, so that the effect of these two forces can be cancelled out. And one thing is that when you're drawing the free-body diagram and then when you're naming the force, you can see that the force must be in this format. The force by something on this object that is what you want to show people. Is because what you want to analyze is the motion of this box. So that we draw the free body diagram on this box. So for the forces acting on the table, acting on the rubber band, acting on the finger is not important. Oh, then how about in a horizontal direction? What force is acting on this box? What about the rubber band? To what direction the force is pointed to? To the left-hand side. And the point of contact between the rubber band is at the very right end of it. Oh, how about the finger? Right-hand side, to the right-hand side. So let's draw these two forces. So the force by the rubber band and is pointing to the left-hand side. Sometimes we can call it tension when you are using a string or a rubber band to hold an object. It's called tension. 要張力啦。Oh, then how about the force by the finger? It should point to the right-hand side. And then the force should be added somehow here. So in the diagram, it should start from the position of the purple dot. Oh, and this force is pointing to the right direction. However, what should the length of the arrow be in order to make the above object remain at rest? Oh, it should be the same length with the green arrow so that these forces can be balanced. Is it okay? And this is the force by a person, and it is actually me on the box. And this green arrow and the purple arrow should be opposite in direction and with the same magnitude in order to make this box remain its original motion state, that is at rest. So here come the free body diagram on this blue box. And again, the format is that it is the force exerted by something, the rubber band or the person, on the box. 我哋諗緊嘅就係話，我究竟有啲咩力咧加喺呢一個藍色盒上面啫嘛，係嘛？其他嘅嘢我哋唔着緊嘅，咁所以個 force 嘅 format 一定係由邊一嚿嘢俾呢嚿藍色盒嘅力。The whole analysis for the vertical direction, the weight or the force exerted by the earth is cancelled out by the supporting force by the table, and then the force of the rubber band is cancelled out by the force exerted by the person on this box so that it will remain at rest. So what happens if I suddenly remove the force exerted by my finger on these blue blocks? And obviously you know that it will be pulled to the left by the rubber band. Oh, and how can it be explained by this free body diagram? Is that, okay, suddenly I remove my finger from this blue box so that the purple arrow disappear. And is at the moment I release the box， 得唔得？我一放開手，我就冇力咧，再加喺呢一個嘅 blue block 上邊啦，係嘛？ Oh, then what is the overall effect? What is the net force? Originally, the net force is 0 because all forces are balanced. Then now, the weight is still balanced by the supporting force, but for the force exerted by the rubber band is no longer balanced by the purple arrow. So what's the net force? Right, to the left-hand side with some magnitude. So this blue box will accelerate to the left-hand side. Can you see the idea? 同埋呢一個亦都喺個 free body diagram 上面度 show 俾你睇啦，係嘛？紫色嗰個我一放手唔見咗啦，嗰個力得翻青色，而家呢支就係個橡筋俾呢個 blue box 嘅，佢自然就會向左手邊加速啦。And the final, the most complicated case is about this experiment. We try to use two rubber bands to hold our object to lift it up. Then why can't these two rubber bands be made horizontal? 咁你可以喺屋企自己試。我用兩條嘅橡筋啦，好似而家咁樣 hold 住一嚿重嘅嘢啦。你咧冇可能令到兩條橡筋咧一定打橫，點解？好 and let's analyze the free body diagram on this pair of scissors. And the first force is a long contact force, the weight or the force exerted by the earth on this pair of scissors. Oh, and then the second force and the third force are obviously the tension by these two rubber bands. Why we cannot make these two rubber bands horizontal? And here is the imaginary case. If the rubber band is really in a horizontal position, and then with weight exerted by the earth on this pair of scissors, if it is really the case, what will happen to this pair of scissors? And now can you tell me why these two rubber bands should not be horizontal in order to make this pair of scissors remain at rest? And maybe here I leave the answer to you. I think you have some idea in your mind.